Hello, I'm Michael Hackney, and yesterday, September the 7th, 2017, coincidentally a Thursday, was a great day for the 3D printing community because KISSlicer 1.6 was released. KISSlicer 1.6 is a major update. It includes some remarkable new features that are not found in any other slicer. It has some great new usability enhancements and some user interface enhancements, and of course it has some bug fixes. And you can use it for free. So let's go ahead and get started. Okay, the first thing you need to do is to go to the KISSlicer website, which also a brand new version of the website launched yesterday. Here it is at www.KISSlicer.com, and you'll see Get KISSlicer on the menu and scroll down to the download link. Download page will load, and here we see that we can get versions for Windows, for Mac OS X, and of course for Linux. I'm running on a Windows 10 workstation here, so I'm going to get the Windows 64 version. So I'll click on that, and the download just finished. It was that fast. So let's go ahead and double click that to launch it. And you'll notice that KISSlicer is packaged in a zip file, and there it is, KISSlicer64.exe. There's not a lot of installation to do. What you do want to do, though, is to create a folder. I happen to have one created on my desktop here. I called it KISSlicer 1.6 Release, and I'm simply going to drag the executable into that folder. You can put the folder anywhere you want. It really doesn't make any difference. Okay, so that's it. That's all you need to do to install. Next up, we're going to run the installer. So I'm going to double click it, and we'll see that Windows has given me a message that it doesn't recognize this app and wants to know if I need more information or don't run it. Well, of course I want to run it, so I'm going to go up and click on the More Info link, and now I can run it, and I'll do that in just a moment. If you're running on Mac OS X, you'll get a similar sort of dialog saying it doesn't recognize the publisher, and it will instruct you to go to the System Profile to the Security tab. And in that Security tab, you'll see a message that says you attempted to run KISSlicer. Would you like to acknowledge that it's okay to run? And you click the OK button there, and then you can go back and you can run KISSlicer. You only ever have to do that once when you install KISSlicer. From that point forward, it's okay. It'll just run every time you click. So let's go ahead and click Run anyway. Now, because we just downloaded and installed the raw application with no other profiles for printers or materials or anything, KISSlicer is going to recognize that and will walk us through a set of wizards to help us create very, very quickly. In fact, it takes less than 5 minutes. It takes less time to do it than it's going to take me to describe how to do it. For a printer, for material, for style, and for support. This is one of the great new features in KISSlicer 1.6. So it's discovered that we don't have a printer profile yet. Let's start the profile wizard, the printer profile wizard. So I'll click close, and here is the printer profile wizard. The couple of things that you need to know: how many extruders you have. Most of us have one extruder on our printer, but if you do have a multiple extruder printer, you can set that number there. Just be aware that with the free version of KISSlicer, you can only use one extruder at a time, so you can only print with one material. If you'd like to be able to use your multi-extruder to do multicolor prints or to use soluble support material in one of your extruders, there is a Pro key that you can purchase for $42. And you don't have to install any new software. You just enter the Pro key into KISSlicer, and it unlocks the Pro features. And the Pro features are really worth it, especially in 1.6. There's a couple of new Pro features that I'll talk about later in another tutorial that in and of themselves are significant. So we're going to go with one extruder. You do need to know your nozzle diameter. For most printers, particularly the E3D V6 hot end, which is commonly used, has by default a nozzle of 0.4 millimeter diameter. The CME CNC raw stock Max V1, V2, V3 all ship with a 0.5 millimeter diameter nozzle by default, and of course other printers may be 0.3, 0.35, 0.4, maybe 0.5. Just know what your nozzle diameter is, look it up or ask on the web if you don't know, and enter it there. The next thing you need to do is pick a firmware type. If you're running a RepRap controller, Arduino based, like maybe a Rambo, or you're running Smoothie, a Smoothie board with SmoothieWare, or Duet board with RepRap firmware, you're going to use one of these, either the 5D relative extrusion or the 5D absolute extrusion. I'm going to choose 5D relative. I do all of my work with relative extrusion, and there's some reasons I do that. It gives me a lot more control and allows me to read G-code and understand what's going on more conveniently. I do recommend, if you don't have a significant preference, to use a relative E. Next up, you need to tell the wizard a little bit about the geometry of your printer. I'm going to be setting up a profile for a Ultabots Delta printer, the Ultabots D300VS. I don't know if you can see it, but there's one right behind me. It's a fairly large Delta, 310 millimeter diameter bed. So I'm going to enter 310. It has a 450 millimeter Z height. It is a round bed like Deltas usually are, and the origin is in the center, as they are on, I think, every Delta I've ever seen. If you have a Cartesian printer, typically your X and Y will be different because they're typically rectangular beds. You don't want to check round, of course. And generally you don't check origin in the center for a Cartesian. Most Cartesian printers' origin is in the front left-hand corner. So just be aware of that if you're setting up for a Cartesian printer. Next, we're going down to the optional advanced settings. If you have a printer with a direct drive extruder, like perhaps an E3D Titan Aero, or on the Ultabots, I've got their micro extruder, which is a direct drive. You don't need to do anything here. This preload is one of the new advanced features in KISSlicer 1.6, which is a remarkable feature, and we'll go into it in detail in an upcoming tutorial. But for now, we can live without it, so just leave the nozzle bore length and the drive length set to 0. If you've got a printer, like say a Rostock Max V3 Delta printer that has a remote extruder with a Bowden tube, feeding the hot end, it probably would behoove you to take a swag at a drive length and a bore length here, and let the system generate preload values for you. Preload, one of the things that it does is help mitigate stringing and blobbing, and it's a very interesting way it goes about doing that. We'll get into detail. So all you need to know right now is measure the length in millimeters from the drive wheel or the drive gears in your extruder, so where it pinches the filament, all the way down the Bowden tube, all the way through the hot end, and then to the very tip of the nozzle. Take a guess or estimate it if you can. So for instance, on a Rostock Max V3, 700 millimeters is probably close enough. It's better to take a reasonable guess than not do anything. So you would enter 700 here. The nozzle bore length is well, what it says. It's the length of the bore of the nozzle. Our nozzle is 0.4 millimeter diameter. In the case of an E3D V6 nozzle, a 0.4 millimeter diameter nozzle E3D V6 will have a 0.6 millimeter bore length. In general, the nozzle diameter is about 2/3 of the length. So if you don't know your nozzle bore length, multiply your nozzle diameter by 3/2 and you should be close enough. Again, not absolutely critical at this point. A good guess, or a good estimate I should say, is better than nothing. Over to the right is another advanced setting that's optional, and we'll talk about this in a future video. For now, let's not worry about it and just leave those set to 0. I'm going to enter in the printer name. I'm going to call it D300VS, and I'm going to click Create, and it has now created my printer profile. Next up, it says no material profile found. Let's start the material profile wizard. Here it is. I'm going to be printing in PLA, so I'm just going to accept the PLA one here. But you can see there are a number of other materials that you can select from, and there are generally good starting point parameters used for each of these. So let's select PLA. The default temperature it comes up with for PLA is 195 degrees C, which is fine. Let's go with that. My printer uses 1.75 millimeter diameter filament. That's common. The other common size is 3 millimeter filament, so you'll either have 175 or 3. I don't have a heated chamber. And then over here, if you have more than one extruder, you'll see that list, and you can check off which extruder this particular filament is in. It's probably not a bad idea, even if you just have one, to check the extruder and be done. And let's call this PLA default and create it. I think I spelled that right. Now it's going to say no style profiles. Let's start the style profile wizard. And styles are basically, the number of perimeters on the outside of the part, the number of shells on the top and the bottom, the type of infill, and the percentage of infill. Those are the core style values, and of course there are many others, but those are the things that you need to think about first. You can actually select one of 5 sort of presets. Take a look at these. I'm just going to go with the default 20%. It works fine for most prints. And it's going to pre-fill in my nozzle diameter, 0.4. If for some reason you wanted to tweak this to get a different extrusion width, you could. Unless you know what you're doing and have a valid reason for doing it, I highly recommend just leaving it at the nozzle diameter. It's a much better way to go. It keeps you out of trouble. So let's call this default 20 style, just so I know that it was 20%. And I'll click create. Now it's telling me no support profiles found. Let's start the support profile wizard. Here it is. And most of the parts I print don't require support. If you do require support, you could select a support type from this this dialog. From this menu. But for me, for now, for this tutorial, let's just keep it simple and say no support. Let's say the nozzle diameter is already filled in for us, so we'll leave that alone. Skirt brim, let's say, none on that. We're all done. Just leave everything default, and let's go down here and say no support as the name for my profile, and click OK, create. And I'm going to go ahead and zoom this up all the way. So here we are. We've just launched into the KISSlicer 1.6 interface, and we'll see over here on the right those default wizards, those default parameters that we created with the wizards are already preloaded and pre-selected for us. At this point, really the only thing we need to do is load a model, slice it, and print it. And that's exactly what I'm going to do. I'm going to load a model. Let's go up here and click open. On my desktop, where are we? Up here, desktop. I've got, where are you? Models from my 3D printed flywheel that I developed. I'm going to choose this model, which is one of the more complex models. And here it is loaded. A couple of quick things on the interface. I can zoom in and out using the scroll wheel on my mouse. I can rotate the part by right mouse clicking and then moving the mouse. And then I can move the part left and right and up and down with a left mouse click. So you can position the part the way you want if you want to take a look at a particular feature. This particular part I used on purpose for this tutorial because it's a non-trivial geometry. These slender pillars on the part, and especially since there are 4 of them and then one in the middle, and you can see the one in the middle actually is like a little gear, are extremely difficult to print without getting stringing between the pillars and getting blobbing on the ridges of these angular. It's not actually a gear. They're there to minimize friction on it's a shaft and a spool rotates around it. And I wanted to use this to show you just how good the default parameters the wizards create are when we print this part. So we've loaded the part. I'm going to go up here and I'm going to click on the slice button, and KISS is going to work its magic and slice this part for me. And when it's done, we will see that the part now is green, showing that it's sliced. Not very useful though, because we can't see the G-code paths, and you can do that simply by going up to the toolbar and clicking this option, Models and Paths. Or if you just wanted to check out paths, you could click the Paths button. I like the model and paths option. That's what I use by default. What it does is show you a ghosted image you can see here of your model, and it superimposes your G-code paths over it. You'll see that right now we're only looking at the topmost layer and only one layer. If you want to look at all layers, you can click on that little button right there, that little checkbox, and now it shows me all of the layers. And I can use this vertical scroll bar to navigate down the layer stack and look at the layers individually as I go down. If you uncheck this checkbox, what it'll actually do is show you the layers one layer at a time. And this is the way I normally work. This is my default setup. I like to look at one layer sort of in isolation so I can see where perimeters start, I can see what the infill looks like, just do the sanity checking that I do on parts before I print them. One thing that's kind of convenient to know is if you click on the scroll bar thumb, you can use the up and down arrow keys to navigate one layer at a time very, very conveniently. The other thing I wanted to show is a lot of experienced KISSlicer users don't even recognize this feature. On the top is a horizontal scroll bar with a path percent label. I can scroll this all the way over to the left, and you notice my G-code path completely disappeared. As I drag it from the left to the right, you can see the G-code path starting to appear, and this is exactly how this layer would print. So this gives you an idea of what to expect when the print is going on. And again, you can use this as a tool to align start and end positions of perimeters and infill and things like that with features on your model so that they're more hidden or anything else that you need to do. Really nice convenience feature. So there we have it. Basically a walkthrough of the major ways of looking at your model, scrolling and moving your model around, navigating through the user interface, and then slicing. And then finally, the last thing we need to do is to click Save. And this will allow me to save the G-code. I'm going to save it on my desktop. Click Save, and now it's going to slice and save the part. And what I will do then is go offline and print this part. And when it's done, I'll show you what that looks like and wrap up this tutorial. And that would be it. One last thing though, this is cool, I just needed to show this. Under Preferences, you can go to the display options and you can actually change the color scheme and the widget scheme for the user interface. And the color scheme, foreground, is the area around the outside of the gray area that you see now around the outside of the main window. Foreground is the orange that you see of the buttons and things like that. Background is that area around the outside of the main window. The 3D background is that main window. And then there are some presets, some color scheme presets. We're currently looking at the default orange, but look at this. The bottom of that list is a new color scheme in 1.6 called Sublime Layers. I wonder how that got there. Thanks, Jonathan, for adding a color scheme for me. And this is the Sublime Layers color scheme, and I love it. It's easy on the eyes. It looks great. Give it a shot. Okay, so what I'm going to do now is sign off and go print this part and come back and show you exactly what we got. Okay, here's the finished part that was printed using the default wizard profiles that were created in KISSlicer for me automatically. As you can see, there is absolutely no stringing and no blobbing. These pillars are smooth as silk. I did remove the skirt and the single layer prime wall around the part just so you could see the base and maybe see the first layer a little more clearly. But this is a really nice looking part. I Skyped Jonathan last night after this part was printed and said I was a little upset that I had spent the last 5 years learning how to use KISS to print absolutely gorgeous parts, and the wizard basically did it in 5 minutes. Now, to be fair, there are some tweaks I probably would make to the default profile to get an even better part. For instance, this one was printed at 20% straight infill, which is what the default profile did.
I always print these parts with the 33% rounded infill. In fact, that is one of my favorite features in KISS, and what really got me addicted to it in the early days is that rounded infill is unique. No other slicer has it. Hexagonal infill doesn't quite look the same. And for my fly fishing reels, in fact, you can kind of see it here. This is exposed. That's what the rounded infill looks like. And in fact, if you look through, I guess there's not enough light, but if you look through the translucent PLA, you'll see the rounded infill inside the part. And that really makes for an attractive piece. And for me, aesthetics are critical in these fly fishing reels. Yeah, you can kind of see it there. Other than that, you know, in terms of this default PLA wizard created a preload setting for me, so it was using the new preload function in KISS, and this is the kind of results you can expect to get with that preload. So I think the preload video is going to be a really important one for people to understand and how to tweak it and set it up for their specific printer. But once you do, it really makes a huge difference in print quality.